Alrighty. So we're going to talk about these three lines which describe how a graph looks. How one of these pictures, like the ones we looked at yesterday, how they look. And it's going to be one of these three. There's no in between. Continuous and discrete are kind of the most clear. And then the discontinuous is anything in between those two. So a continuous graph is a single line or curve with no breaks. The easiest way to test it is to literally take your writing utensil and trace it. If I never pick up my pen, never once, it is continuous. This squiggle is just decoration. So I never, ever, ever once pick up my pen, aside from on one arrow and on the other one. I'm going to pop down to discrete, just because those are the two kind of extremes. Discrete is individual points. No lines, no connection. I think the blue disappears. No connections. I know it's weird that it switches color in the middle, but otherwise it doesn't show up on that dark section. And discontinuous is anything in between. Might have some lines, might have some swoops, might have some dots. Okay, next time you go get a kiosk pass. Next time you go get a pass from the security officer. Just because I've already sent attendance in. I got you right now. So anything in between. It might have some breaks. It might have some lines and something in between. It might have a jump or two. But it's anything in between. And that's really all we're adding today. Is this a single line with no breaks? Is it individual points? Discrete looks like the scatter plot one. Or is it somewhere in between where it's discontinuous? So continuous and discrete are the two easiest to spot. And so we're going to look at those same pictures from yesterday. I wasn't going to make you new graphs for the single word thing that we're looking at. So we're looking at those same pictures from yesterday. So is this continuous, discontinuous, or discrete? Continuous. Literally, I'm going to put my pen on one and I'm going to go swoopy-doopy-doopy-doopy-doopy-doopy-doopy-doop. I never picked my pen up. That is the ultimate test for continuous, discontinuous, and discrete. So this is continuous. Ta-da! You did it. We're going to look at this one. Is this continuous, discontinuous, or discrete? I would say, ooh, contingent. I love it. Let's test it. So what we're going to do is we're going to start at one end, come down here, and then, oh, here's a hole. I have to hop over it. So I'm going to pick my pen up, put it back down, and I've got another swoop. So since it wasn't one continuous line, we know it's not continuous. But there are some lines, so it's not discrete either. So it's the one that's in between. This one is discontinuous. Another way to think of this, if you remember like your English prefixes and stuff, this means not continuous. We just can get occasionally more specific when we have something that looks like that one. Because what's this? Discrete. It is a speckled little scatter plot. That means this one is discrete. Which I can never remember how many E's are in the word discrete. Spelling comes with a grain of salt. A lot of you guys noticed in the Algebra 2 bin, and I'm thankful for that, the homework worksheet from yesterday that I said I'd have for you and then I didn't have. I have it now. So we're going to do one of them from the homework page. So if you did not pick up the worksheet, go grab it. Or if you started the homework on Lucy's paper, that's totally fine. It's in the standy uppy folder or file thingy labeled Algebra 2. Yep, right there. Because we are going to look at number 5 because it's a little funky. So yeah, number 5 looks a little weird. So I wanted to work through this one with you. That'll also kind of give us a refresh on the stuff we talked about yesterday before you guys get like the rest of the time to work on this and finish up this homework. Okay? So we're going to identify our domain and range. We have 2 little pieces on here. So what I'm actually going to do is I'm going to color code so we can talk about them. This one we're going to call purple. And I'll do the other one in blue. Just so that it's easy to talk about. But, I mean, it's just a me thing. Okay? So, first things first, we're going to talk about the domain. And whenever you have something that's in cut in pieces like this, it's sometimes just easier to look at each piece by itself and do the domain of each piece. So, if we just look at Bluey over here, how could we write this domain? Remember, domain is about my x's. Domain is a Taylor Swift. What is the biggest my x's can be on this blue segment here? -2 is going to be my biggest, right? What is the smallest it's going to be? -infinity. So you could write this a couple of different ways, and you do not have to write it both ways. So one of them is our -infinity to -2. What is that negative sign? There we go. -2 with a parenthesis here because infinity is an idea. And then is this going to be a parenthesis or a square bracket here? Square bracket because we can touch it. So that is one option for writing this. The other option, you, again, do not have to do both, is that your x's have to be less than or equal to -2. Those 2 pieces mean the exact same thing. I have written that it is both orange and tangerine. They're the same dang thing. Okay? You do not need to put both. Whichever one works better for your brain, pick it. One of those will feel better on the wrinkles. Okay? If you like the inequalities, do that. If you like the bracket thingy, do that. Just know how to read both, okay? So let's do the domain on purple. What is the smallest that purple can be? This one. 1. That's coming up, looking up here, looking at just our x's. This is a 1. What's the biggest it can be? Infinity. So again, I'm going to write this one both ways. We could either say that it is 1 to infinity, in parentheses on infinity because it's an idea, and we can use the 1, so we're going to use our square bracket. This one is our interval notation. You also could say x has to be greater than or equal to 1. 2 different options for writing it, and neither one is better than the other. They are equally good. They are equally valid. One will make more sense for your brain. What's up?
Does it matter if you flip them, like infinity first and then 1, or does it have to be?
It is supposed to be smallest to biggest. So put your infinities on either end. Is the easy way to remember that. But yeah, we do want to go from smallest up to biggest across the trend. So it should always go from left to right. Questions on that one, on our domain? You can do the same thing for range. Totally fine. The other thing to notice is they kind of overlap a lot in range. So we only really need the one that covers more. But we can do both ranges. It's totally fine. What is the range for blue one over here? -1 is the smallest it can be. Is this going to negative infinity when it's going up here? To positive infinity. Positive's up there. So this is going from -1 to positive infinity. This is one of those times when it really shows you how that order matters right there. Because yeah, -1's the smallest that blue can be. But it goes up to infinity. What about purple?
Infinity to -2? Oh, -2 to infinity.
-2 to infinity. Because infinity is bigger. Oh, and it's not, this one's not -1, that one's +1. I don't know why I wrote negative. But do we see how they are covering the same range? 1 to infinity has a lot of overlap with -2 to infinity. So we did more work than we need to because this one includes this one. They're covering the same range here. So you could just write this one. And if we looked at like an answer key and stuff, it would just have this one. I'm 100% okay when we have a piece like this and it looks kind of funky and it looks like 2 rays, if you remember your geometry stuff. I'm totally fine with you doing both. It's more work. You practiced it again. Go team. Technically, if you look at an answer key, this is your range. Yes, my range.
So on negative infinity, it's always on the left, and then regular infinity or positive infinity.
Correct.
Right.
Negative infinity will always be on the left. Positive infinity will always be on the far right. Because that is the very, very smallest and the very, very biggest it could be. Select this on our domain and range. Because we did those yesterday and it's just really different. So like these two numbers here? Mm-hmm. Versus the -2 for domain or versus the -2 for purple? This negative 2 or this negative 2? There's too many negative 2s. This one. Because, so that's part of the reason I have them in two different colors is this one's the blue one. This is the range for just this piece. If my picture looked like that, and it was just this guy, that's the information for the blue piece. This is the domain for blue, the x's. This is the range for blue. So the negative 2 comes from the x value here, this negative 2. It's 2 spaces to the left. This 1 comes the fact that it's starting up 1. So my y value of 1. Okay? Cool, cool. All right, how we feeling on that? Then we're gonna do our tests. So we're circling which ones are true. So we've got function, one-to-one function, continuous, and discrete. We could wind up circling 3 out of 4. Possible. That's the most we're gonna get. It will never be both continuous and discrete. Can't be both. So first things first, let's see, is it a function? That is when we grab stick of power. And teach Macy stick. Is it a function?
No.
Yes. It is a function. Boop. Is it a one-to-one function? No. Because up here it's crossing more than ones at the same time. It is crossing my horizontal line here and here. So it is not a one-to-one function. You don't have to cross them out, but I sometimes like to. It helps me keep track of where my brain is. Is it continuous? No. Because if I trace my line, I have to make it hop. I'm going to go trace, 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 trace. Oh, I have to move. And then I can go again. So it is not continuous. Is it discrete? Speckles only? No. This one is discontinuous. So if we had that there, we could circle it, but we don't. We have continuous and discrete because anything other than those two is discontinuous. And you can write it if you want to practice that. You do not have to. This one is discontinuous. You don't have to write that in. But I know sometimes we like to have a thing to circle. And you can't. Yes, my friend.
Can you explain what a function is?
Function, that's our vertical line test. That's each x goes to only one y. Vertical line. Like this. That's when we go across our graph this way. And we say, does it ever cross more than one time? So here it's only crossing one time. It only crosses right here. And I can follow it with my finger. It's only crossing one time. I only need one finger. It's okay if it drops. I got nothing touching here. And then here it starts again. And I still only need one finger to trace it. If we look at something, I can give you a picture. Let me see. I need a blank page. Yet another, oh, let's see. We'll extend it down. If we had a picture that looked, we're going to get our graph, pretend graph. We're going to go like that. And I bring my vertical line test over here. I can trace my line here, and then it comes up, and then, oh no, I have 1, 2, 3, stop, I can do that. 1, 2, 3 different places that it's crossing this vertical line. This one is not a function. It fails that vertical line test. If it fails the vertical line test, we do not need to do the one-to-one test. It cannot be one-to-one if it fails the vertical line. So always check that first. Okay? Good question. Good question. Any more questions? because I want to give you time to ask questions and work on stuff. I know yesterday we talked to the end, and I don't like to do that, but it was one of those, it was a really weird place to come and break out. So this is homework 1-1. It is a worksheet. It is also questions 1, 2, 18, 19, 21, and 31 from your book. So it's the same questions. I just put them on a handy dandy worksheet for you. So that is homework 1. You guys have the next 20 minutes to do it. Ask questions, work on it, look through it. If you get it done, you can turn it in. Like, you don't have to take it home. Okay, yes, ma'am. Yeah, absolutely. As long as it's not like I can hear it at my desk loud, you can listen to music, totally fine. Usually I will toss on a little instrumental music just because I don't like silence. Yes, my friend. Okay. So let's look at a different one then. So why don't you flip over, we'll go to the other side. These ones are, I like this one. This is a good one. So we're looking at our domain first. And another way to think about it, sometimes it helps if we think of domain as our x's, right? I want to know what x's work. I don't care how wiggly squiggly it is. So if we imagine smashing it flat, right? That makes our wiggly guy go floop, right? So I'm going to have arrows that go out to both sides, right? That's going to be all real numbers is what that is. All of our numbers. Any number I can imagine in the entire world. Because I could use 0 for my x value and I'll get a spot on my line. I could use 3 for my x value and I'll get a spot on my line. I could use negative 500 and I'll get a spot on my line. It's just going to be way down here. But it's got arrows, so we see that. So our domain can be any number in the entire existence of the universe. So we just call that all real numbers. Our range, that's looking at our y, so we're looking the other way. You imagine smashing it flat this way onto this axis. What's the highest my y values can be? What's the highest it goes on the graph? Does it go up to infinity here? What's the highest it goes? Here. Yeah. So the highest it's going to be is 2. What's the smallest it's going to be?
Because it's 1, 2.
Okay. What's the smallest it goes?
Smallest, it can go here.
It never ever goes below that spot, even out on the edges?
Here's the...
Where is that headed? Does it stop there, or is that heading down?
Heading all the way down?
Heading
So
all
that's
the way down.
infinity?
So that's our negative infinity, yeah. So for our range, the high...
First, you put the lowest first.
So you put the lowest first, yep. So you can give it like a number line here. We always put the smallest ones on the left.
Is the infinity the lowest?
The negative infinity is the lowest, yeah, because it's going down. So that's, you're gonna put that on this one. That one, it's all good. Beautiful. And the highest it was gonna be?
2.
Gorgeous.
And
Yes. Perfection. Glorious perfection. Okay, gorgeous. So for the domain, if you want to do it the same way as this, that's when we say, all right, this way is our negative infinity, and this way is our positive infinity. Totally fine. Absolutely do that anytime you need to. Yep. And since I've got my 2 arrows that are going out, imagine it flat, I'm going from negative infinity to positive infinity. Okay? And that's what you write there.
how do you write that down?
Just like you did this. So our smallest one was, and the biggest,
It was positive?
And that's totally fine. If you want to put the pluser, 100% okay. Okay? It's a perfection, glorious beauty.
What if it wasn't like infinity in the arrows? Or is it always going to be infinity in the domain?
It's not always going to be infinity, but there's usually going to be an infinity involved somewhere. If you've got an arrow, there's going to be an infinity.
Is positive infinity?
For the y's, yes, that is positive infinity. Because it's going up.
What if it was here, still positive infinity?
Still positive infinity. Yeah. These are the positives on the y and the negatives.
And the domain are the arrows? Like,
Domain is this way. Range is this way.
So domain is this way,
Yes.
and range is.
That, yes. Yes.
Alright.
Yes.
Thank you.
You're welcome. Just 1 second, let me put my stuff down. And figure out who's at my door. Oh, okay. You say, I guessed. All right. Oh, it's your birthday. Happy birthday. No, it's going like that. Yeah. Yes, dear. It's the same exact questions that are in the book. Okay, I just made it as a worksheet, or you can do it in the book, whatever you like. Second shelf, the big white that says turn it. Yes, sir. Hi, Nancy. So the domain we're looking at what x's work, right? So one does work. I mean, that's better than one. Okay, more things that work. Yeah, that works. That's 0. It works. Is there any number that won't give you a spot on the line? Not you. Oh my gosh, no gosh. No. Yeah. Is there anything that won't? Or can I pick any number and you choose these over there? Yeah. Good instinct. Good job. Okay.
What kind is this? Anyone?
We're looking for that all our numbers. That was your answer right there.
Okay.
Uh-huh.
So,
Then you move on to the next question.
so it is all the numbers.
Uh-huh.
You get to look at it.
All our numbers. That totally works.
That's, is that the R?
It's on PR. Correct.
Right on.
Is it the same? Yes, it is. It's not always gonna be, but it is. This one. Yes. Okay, you overthinking it. It's all good. You do great. You got it. They're in the back on the file on the shelf.
Okay.
Yes, we do. Okay. Correct. Correct. Uh-huh. Uh-huh. So you could do the infinity one with correct stuff? Okay, so what's the smallest it can be? What is it, what do we mean, what does it say when we get the most? Forever and ever and ever and ever. Perfection. And then big. Glorious. Perfection. Perfect. Absolutely perfect. Yes. Same. Uh-huh. And so then do it today. Because it is the same one. Good. You got it. You got it. You're overthinking it. That's okay. That's why we've got the pen and practice it. Yes, we do. Yes. Does it ever cost your pencil more than 1 half? So that's a pass. So it is up here. Yes. Yes. Does it pass that test or does it fail that test? It's the same rule, it's only gotta cross 1 time. So it hits 1, 2, 3, 4 times. So it fails that test. So it is a function, it is not. Okay? Yeah, what's your password? You're Gabby. Sweet. Just make sure I got you in the right spot. Thank you. do our function test this way, right? Our vertical line test. And it's only gotta cross one time. Our one function test is this way. Does it cross one time?